Okay, we're going to get on here. This is Melissa Hanson. I'm the Research Program Director for the Washington State Wine Commission. Welcome to the last of our spring 2023 WAVEx webinars. Today we have Dr. Michelle Moyer, who has been working on nematode management for over a decade. And so this is a kind of a summary of some recent research that was published. She's able to take long-spanning research and bite it or put it together in little bite-sized pieces. So, you know, rather than try to report on everything, today is just a look at one segment of a lot of years that she's put in. Just as a quick reminder, we are video recording this, and so everyone will get a recording. Okay, screen's not changing.
Melissa, sometimes you just have to re-click on your actual PowerPoint and it'll change.
Yeah, there we go.
I love Zoom.
So just a reminder to ask your questions in the Q&A. The chat, we can't see your part of the chat. So I am going to stop sharing and Michelle will take it from here.
So I'm going to do that. We're going to do that. We're going to share.
There we go.
I'm hoping you guys can see my screen. I'm guessing yes.
Yes.
Perfect. I'm just going to give me a quick second as I rearrange some other screens. For those who've done Zoom a bunch on the presenting side, know they end up with about 17 screens open and they all look like the ones you're supposed to access. So, all right, now I think I'm ready to go. And thank you, Melissa, for that kind introduction. As Melissa mentioned, we will be looking at a very small segment of some of the work myself and my team. And my team, I mean both individuals within my program and a big component of this, which is our work with the USDA ARS down at Corvallis, Oregon, Dr. Inga Zasada too. So she's our nematology lead here. So we'll be looking at a small component of that work in the last 10 years. And Melissa, I know you say it's little bite-sized chunks, but the problem with bite-sized chunks is you can choke easily. So hopefully this doesn't become that. And we have some interesting, you find this presentation both interesting and semi-entertaining for whatever it's worth. All right. Again, as Melissa indicated, nematode research often takes a lot of years to do, or to at least do well, where we understand and learn about a system, particularly in perennial crops, where our intent is to obviously not grow something annually, but over a long period of time. And in particular here, we were very fortunate to have funding to span what is a 12-year project. That's pretty rare with a lot of academic research to be able to do that over a long period of time. And that is because of the funding through the Washington State Grape and Wine Research Program and their not only ability to allow us normal smaller grants, but to think about projects that span multiple years. So super thankful for that. Of course, big trials that you'll see me present on require, can't do it on WSU property just simply for the duration and size of some of these projects. So we do partner with you guys in the industry. And we could not do a lot of these projects without Inland Desert Nursery providing some of the plants for the research. And then one of our biggest research collaborators, St. Michel Wine Estates. So they've been extremely helpful in this. And then of course, all the people who actually do the work, I just get to talk about it, but we've had a number of grad students and postdocs work on these projects over the years. And of course, my partner in crime is Inga Zasada down at the USDA ARS. As we like to say, I play a nematologist on television. She's the actual nematologist in the system, but it's been a really good partnership for my team to be able to work on bigger picture IPM questions and a lot of the plant physiology, and she gets to delve into the nematode side of the research. So pretty fun partnership. You know, that when we really think about plant parasitic nematodes or soil-borne pests from a big picture management perspective, they often get kind of shunted to the side. And that's really because there's so many factors when thinking about vineyard establishment or replant that often kind of managing those soil-borne pests or diseases really becomes kind of an afterthought. You know, you're not going to be thinking about nematodes when you're crunched for planting timelines, trying to select varieties that perhaps survive a winter here in northern production systems, trying to source your certified stock because we are obviously afraid of virus diseases, And then obviously in sometimes it's just figuring out who's going to even buy the fruit. And then when you're factoring in all those decisions in a pre-plant or replant situation, it's only right before you plant suddenly do factors related to soil management come into question. And often that, because we're giving such little time to be able to consider that question, we make a quick decision. And in the case of nematode management, that quick decision is the use of pre-plant fumigation, kind of clean the slate, move on. And that is an approach. It's a valid approach. But I think over the course of today's presentation, hopefully we will maybe delve a little bit into why we maybe need to think about that approach a little more. Maybe it still stays valid, but in some situations, I think you'll find that perhaps there's alternatives that work just as well. When we think about today's soil-borne pest, a nematode, it's being a very small microscopic roundworm. We often, just don't even know how to conceptualize what a nematode is and what it does. And very few folks actually see nematode damage in root systems kind of early in that damage process. So I wanted to show you guys what those look like here. And so what you're seeing here are two root systems of a 2-year-old Vitis vinifera vine. So this is Chardonnay here on the left, Cabernet Sauvignon on the right. These are grown in pots. So just kind of think about that system here. And we've inoculated them with root knot nematode, northern root knot nematode. And I just wanted to highlight what those root galls look like, right? Because you'll see a lot of galls on the internet if you Google search images to help diagnose, and they often are very difficult to see. But really what ends up happening as the nematode invades the root system, it really enlarges the root tip and creates these kind of mangled gall tips. It looks a lot like, honestly, like phylloxera galls on roots. But you can imagine over time, if you get enough root damage like this, that does limit the root's capacity to take up the water and nutrients. And that's ultimately what kills the plant, is the plant actually dies or looks like it's dying from drought stress or nutrient deficiencies. And it's just because nematodes are a challenge to that capacity of the plant. But that is something to think about from a nematode perspective, is that in many cases, we often view nematodes, or they can be viewed as a secondary pest, because they themselves are not really directly killing the vine in many systems, but what they're doing is adding stress to a system, right? And that's the hard part with nematodes too, right? If I was here talking about powdery mildew, downy mildew, botrytis, other diseases, when we think about grapevines, and there's a very real visible loss of either the plant or fruit quality at the end of the season, that's a really easy thing to describe as being a problem. But when you talk about a pest that is mostly just kind of hindering or not allowing the vine to live to its full capacity, that's a really difficult concept to present. And so if we think about what a productive vine is in a vineyard, a vine that's healthy, you're getting the yields you want out of it, the growth, the fruit quality is what you want. They can handle nematode feeding. They can handle some nematode feeding. Nematodes are not this zero tolerance situation. Vines in a system can actually handle a bit of nematode feeding. But we get worried about nematodes in the sense that if there's any other stress factor going on in that vineyard, whether it's excessive deficit irrigation or a drought year for vineyards that are dryland farmed, if there's other pests or diseases or nutrient deficiencies, suddenly those stresses start to really kind of impact the vine. And then any added stress, like the stress from a nematode damage, can push that vine over the edge. And alternatively, especially in a lot of replant situations, which Washington is starting to get to that stage, when you have a very large old vine root system with a lot of fine roots growing in all sorts of different directions, you can imagine that root capacity could probably handle and hold a lot of nematode feeding because it's got a lot of compensation going on throughout the system. But when you plant a very young vine into highly infested soils of nematodes, you can imagine that very young vine can quickly get inundated. And so in that situation, nematodes can become a primary pest of a vine. And so what that translates to when we think about nematode is we use nematode damage. We think about two different terms, a chronic decline, so very slow death over time, or acute decline, something that happens very quickly. And when we deal with a brand new vineyard planting into soil that was perhaps not under an agricultural system before, most nematode feeding, particularly with the northern root knot nematode, tends to be that chronic decline. It's a slow buildup of nematodes in the soil over time, and it's a slow visible decline of that vine over time. And again, that's because It's really not the nematodes themselves that are likely going to cause that vine to fully term or die early. It's that the nematodes plus all the other stresses that are going to be hitting that vine over the course of its lifetime. And replant, because we are planting into potentially really high pre-existing nematode populations, that decline can happen more rapidly. I use the term acute. A lot of folks think, okay, planted in the first season, dead in the first season. Not the case. It's more like planted in the first season, maybe dead in 5 or 6 years, but that is definitely more acute, if you will, than a 30-year chronic decline. And really, when we think about fumigation, the question behind a lot of our research here, when we think about nematode management and fumigation and what to do, is related to this situation right here that we have in red texts. Is if you start off behind, so in other words, if you plant a vine into a nematode infested soil, can that vine ever kind of catch up or still be productive in that system, or are you always going to be behind? And when we think about the duration of a vineyard, that 30-year lifespan, that is a legitimate question that we have to ask of where are we willing to put our risk? Should we plant quickly and not fumigate, kind of save soil health, that kind of thing? Or do we need to fumigate because that really has long-term consequences? And that's the intent of our research. But you know what, this is a Zoom webinar. So before we transition to start talking about potential management options, Melissa and I are gonna, and pardon, please bear with us, we're gonna try a little experiment here. We're gonna do some poll questions. And so this is just to see if you're awake. So if you can, Melissa's gonna launch a poll here to have you answer the question of if you have tested or have you tested your vineyard for nematodes. In this situation, we just want you to, so Melissa's showing all 3 questions. I'm just going to have you guys answer question 1, and she will relaunch a poll later with our other 2 questions. So again, just answer question 1. We'll give you guys about 10 seconds to do that. So have you sampled your soils for nematodes, your vineyard soils for nematodes? And this can be at any point, last year, 10 years ago, whatever, just at some point in the production of vines, have you sampled your vineyard soil? And so Melissa, I think you can see the rate at which questions are coming in. So I'm going to let you judge when the poll can close, and hopefully you can share the poll results with us.
Yes, we need a few more people to respond. Oh, some are responding to all 3 questions.
Yeah, please don't respond to all 3 questions. Respond to question number 1 only. She's going to launch a new poll with those other ones. The poll settings have changed a little bit in Zoom, so we're still figuring that out.
Yeah, sorry.
No worries. And so Melissa, when you feel comfortable that the rates coming in are slowed down, you can close it and share the results.
Okay, we're going to close now.
Okay. Don't have a vineyard, some yes, some no. Okay. Interesting, and probably what we'd expect.
Yep.
All right, thank you, Melissa. I don't know if you can close the view. Beautiful, excellent. See, this is working out great. I'm awake. Are you awake? All right, so let's move on. So you guys, if those who have tested your soils for nematodes know that you get this number that is sent back to you, right? So you've sent in your soil for a nematode test and they send back, you have X number of nematodes in your soil sample. And I will agree with you that that number is often very difficult to understand, to interpret. And I'm going to try to walk you through that. But I think hopefully if we thought about the concept of acute or chronic decline, and we think about the concepts related to that stress, those numbers should be difficult to interpret, because that number is relative to the overall health of your vines. A number that might cause a nematode density that might exacerbate decline in your vineyard might be a different density than would exacerbate decline in a vineyard that's managed differently than how you're managing. So what I'm showing here is a table that we often share in our IPM guides here for the Pacific Northwest. And in it, you'll see an average density in Washington vineyards. So about 15 years ago or so, Inga and her team did a statewide survey of wine grape vineyards and what the average nematode density was for root knot, dagger, ring, and lesion. And these were the average densities that they found. So they created these kind of thresholds, which what you see over in this threshold 3 box, of nematode numbers that would probably trigger you to do some sort of management action. So if you came back and it was 100 root knot nematodes for 250 grams of soil, that might be a trigger for you to do some management. But it's really not that easy. Because if you have a really young vineyard or a very stressed vineyard, maybe that number is 50. So something to think about. And in some cases, some nematodes in certain systems, you might have them and they are plant parasitic nematodes, but maybe they're not ones that you really care about. So that's something to think about, is that the number of nematodes and that those densities of those nematodes are specific and of what will cause damage are specific to the basic health of your overall vineyard that you're managing and to the nematode species you're trying to target. And I think that's a very interesting thing to think about, especially when we start to compare management practices in warmer grape production regions versus cooler regions like here in the Pacific Northwest. So up here in Washington State and across many of the northern states in the US, the nematode species one of the major root knot nematode species that we're concerned about is northern root knot nematode, right? So root knot nematode is a nematode that causes all those galls all over the root system. In warmer locations like California, they're working with they have northern root knot nematode, but they also have another nematode species called southern root knot nematode. And the differences between how these two nematodes behave is really important when you think about how effective different management approaches are. So the northern root knot nematode is called such because it can actually withstand really cool soil temperatures. Makes sense. It's northern root knot nematode. Its eggs can hatch at lower temperatures in the soil, but it produces really small galls. And typically, especially in our climate, we really only see one generation a growing season. And what that means is that this particular nematode, when it feeds, is not as aggressive as other root knot nematode species. And it really only can do, the feeding buildup and damage will take much longer to visualize in a vineyard. And I think that's why historically in Washington, we haven't really cared a lot about root knot nematodes because we have a lot of new vineyards going in, and it just has taken a really long time for for this particular nematode species to build up in our soils. In California or other southern climates that are dealing with the southern root knot nematode, that's a difficult nematode to manage. It does like warmer soils, as one would expect, but it produces much larger galls on roots. And it has multiple generations a season, so it's just constantly reproducing. So you can imagine this particular root knot nematode is extremely aggressive. And so it is a nematode that folks have to manage for because it can build up very rapidly and cause more of that acute decline that you see in vineyards. Other nematodes like dagger are something to be concerned about, but you really have to think of why we're nervous about dagger nematodes. So yeah, dagger nematode itself can feed on grapevine roots, and it can reduce vigor if there's a lot of them, but they really don't really build up to that a lot of them level. Often in grapes, the reason why we're concerned about dagger nematodes is because they tend to vector nepoviruses. So nepoviruses are viruses that are vectored by nematodes, hence nematode and virus. And the big one that I think a lot of us are really familiar with is grapevine family virus, and that's vectored by the dagger nematode Xiphenema index. Washington State does not have, to our knowledge, Xiphenema index in our soils. So in this situation, we're not really concerned about our dagger nematode species in terms of the vectoring of grapevine family virus. The Xiphenema species we do have in abundance in a lot of grape vineyards are the Xiphenema americanum group. These guys do vector viruses like cherry rascal leaf, tobacco ring spot, and tomato ring spot. And I will say tobacco ring spot and tomato ring spot do show up in vineyard virus samples from time to time. But these two virus diseases on grape tend to be, again, very slow building of virus and often just cause some leaf discoloration and very minor impacts on fruit unless it's the vineyard is pretty stressed. So in general, when we think about nematode management in Washington State, when I start to refer to that through the rest of this presentation, I'm really predominantly talking about the management of northern root knot nematode because it can cause galls and more directly damages the grapevine. All right, knowing that many people attend plant disease presentations because they want their certified pesticide applicator license credits, we are doing that. We are providing that for this presentation. So Melissa didn't mention this, but she has procured, I believe it's 1 credit, both for Washington State and Oregon State. And so what I would like you to do on a piece of paper next to you, or remember it in your brain, the code word spring. So I want you to remember that word or write it down. Again, the code word is spring. And then later in the presentation, we'll provide you instructions on how to provide us with your pesticide applicator number license and this code word so you can get credit for attending today. So again, one more time, write down the word spring. Tried to make it very easy. So spring that we will ask for later in the presentation so you can provide that information to Melissa. All right, it's okay. That's another business item out of the way. All right, so we talked about the different nematodes that we have in the state. Let's talk about how we manage them. And there's kind of three big approaches, and this is true pretty much for most pests and diseases, is that we have chemical approaches, we have genetic approaches, and we have cultural approaches for management, and nematodes are no different. For nematodes, chemical approaches include a pre-plant fumigation process and post-plant chemical treatments, just like we do in many other pests and diseases. But we do start to ask questions of how each of these different types of management approaches may or may not be most effective for your individual farming operation, and of course, Washington State as a whole. Pre-plant fumigation is predominantly the major means for nematode management in Washington State. We've definitely tried it, but I'm going to ask this question of whether or not it's true, and that's where you're going to see research discussing this, aspect of fumigation for the rest of the talk. But some of the big questions we have on fumigation, especially in perennial cropping systems where we're asking fumigation in 1 year to provide management for 30, is does it last? And of course, with fumigation is what are the other negative or what are the other consequences of fumigation to soil health and other aspects? And maybe it's not always negative, but just it's a consequence of. With post-plant treatment, I will say Inga and I have done a lot of post-plant evaluations, and what we do know is, just like with pests and diseases, chemistries are usually very specific to the nematode species, but for those of you who use or have used post-plant nematicides, recognize that often they just say nematodes. And what does that mean? Is it root knot nematode? Is it dagger nematode? What is it? So I think a lot of these products are just not quite there yet in terms of specifying what they target. Depending on how you apply them, you can have coverage issues. Some nematicides post-plant are sprayed on the canopy and the plant absorbs that. Others are applied through the drip system. And if you can imagine, if you have any broken or clogged drip emitters, that can be a problem. Or if you are inappropriately timing that injection into your fumigation cycle, you might result with products in the upper surface or leached below the root zone. And again, since some products, they probably work in a species-specific manner against eggs or a juvenile stage, that obviously will change the timing because every nematode species has different timings of when those different stages are present in the soil. Genetic approaches in grapevines for nematode management usually revolve around rootstocks. There's been a lot of breeding efforts for breeding rootstocks to be resistant to either broad swaths of nematodes, such as general nematode resistance, or species-specific. The challenge with breeding a crop to be resistant that you then plant and keep in the soil for 30 years is, what does resistance actually mean? And we're probably, in the case of nematodes, it's not actual true resistance where the nematode just doesn't feed on it. It's probably a situation where it's partially resistant, where the nematode can feed on it, but at a very slow rate of development. And so practically, from a production perspective, it's viewed as resistant. And then with cultural practices, the two big ones are fallow periods where you don't grow a crop, with the idea that if there's no host for a nematode on which the nematode could feed on its roots, the nematode would starve. But really, is that physically possible? How long does a fallow period need to be? In our hot, dry climate, fallow could probably be used to our advantage. But if you have to use any kind of irrigation for dust mitigation, that could allow weed species to develop, and those weed species could be hosts for nematodes. You could also use cover crops or green manures. Many different plants have fumigant or nematicidal properties based on some chemical components that are in them. We're not really going to go into too many details on those, but those could be potentially integrated into the system. But for the most part, they're best used in a suppressive manner. So they are a complement to other nematode management activities. And of course, we have the question of, where do you plant them, right? Do you plant them where they're in Eastern Washington, where there's water, which means under the vine or kind of in that vine row? Or do you plant them where most traditionally you see cover crops, which is in the valley, in the vineyard alleyways or between the vine rows? But of course, if you're trying to suppress nematodes, you should plant them where the nematodes are. And in our case, that's under the vine. And what does that mean culturally? Lots of questions there. So we're going to try another poll here. We'll see if Melissa is ready to do that. And the question is what approaches do you use for nematode management? So What have you used in the past? Or, if you haven't, that's fine. You don't have to answer the question. But Melissa, are you ready to launch a poll here? There we go. So I want you to answer the second question. So we'll see if folks are listening. The second question on what approaches you have used for nematode management, and you can select all that apply. I'll give you a couple questions there, and I'll let Melissa call when she would like to close the poll. So again, we're having you answer question number 2. Question number 2. All right, so pre-plant fumigation, okay. Post-plant chemical application, that makes sense because not a lot of things are at 0%, not a lot are registered in Washington. Cover crops at 75%, rootstocks at 75%. So that's interesting. That's either you guys are just now starting to do that, or we have folks not from Washington answering this question. So that's intriguing. So thank you, Melissa. I think we're good there. Perfect. All right, and we move on. All right, so when we think about those different management options, and I promise I'll actually get to some data here. Well, this is data too, but I guess we'll get to the meat of the fumigate or not. When we think about pre-plant fumigation, I asked that question of it's definitely tried. We've done it, and I know more than 25% of you have used pre-plant fumigation. But the question is does it work? And some of the challenges we have with pre-plant fumigation is the fumigant going to where the nematodes are going? And that can really differ. That question of where nematodes really differs whether you're working in a dryland farm situation or a irrigated situation. So in irrigated Eastern Washington, when we sample for nematodes, we find nematodes where we find grapevine roots, and we find grapevine roots where there's water. And we see this here in this image. And so this is some work that Inga and I have done, and then of course, Dr. Catherine East, I don't know if she's on this call or not, this is her work as well, where we've sampled pretty intently in a vineyard to see how, where across to vineyard rows and how deep we find northern root knot nematode. And what you're seeing here is where my red dot here is, that's where a vine would be, goes out to the middle of the row alley. This is where a vine would be. And going up and down, that's depth in soil. So, between 12 and 24 inches, 36 down to 48 inches. We find almost all the root knot nematodes directly in the vine row under a drip emitter in the top 24 inches of soil. So that's where northern root knot nematode is. You can imagine if you have to fumigate, that's where you have to fumigate. If you're drip applying a fumigation in a replant situation where you've chosen to keep a trellis system in place, one might say, well, that's actually pretty good because you're drip applying where the drip was going before, which is where the roots are. But if you don't time that fumigant correctly in their fumigation injection, you might end up where your fumigant's only in the top couple inches of the soil or way below, and then you have a bunch of nematodes that essentially are untreated. If you're shank applying that, the real question is does that injection go 24 to 36 inches deep? And I'm guessing, like with many things, you're going to have a gradient of efficacy as the farther away you get from where that injection actually happened. And so that's one of the challenges is fumigation, the coverage, if you will, is never complete because we're dealing with a very variable soil, and nematodes are mobile pests. Same thing is true with dagger. So you see the exact same picture here. So this is Xiphonemia americanum. And what we find, again, highest concentration of dagger nematode right at the vines under the drip emitters, but dagger goes much deeper. And we also find it in the vineyard alleyways as well. This dagger nematode has a pretty wide host range, but where we don't find it is in the top part of the soil, like it's disturbed a lot. So dagger does not like to be disturbed. It doesn't like tilling or compaction. So we tend to not find a lot of dagger right in that vineyard alleyway. But again, if you can imagine, if you're fumigating and the fumigation only works right here, if you're drip applying it, you got all these dagger nematodes elsewhere. Or if you're shank, again, it can only go so deep, and again, nematodes can move back up. So that's one of the challenges with fumigation. It really only works in the part of the soil in which you're fumigating. And if you're growing an annual vegetable crop or a biennial vegetable crop, awesome. We're not likely sending a whole lot of roots into these other areas, and you just fumigate every year. I mean, we can talk about sustainability on that, but that is a very functional, practical value and usefulness of fumigant. But when we grow a perennial crop system, and eventually where those roots will go to greater depths, and we plan to keep it in for a long period of time, you can imagine then that the fumigation may not have a long-term effect. When we think about post-plant fumigation, as I mentioned, I just don't think it's quite there yet. I think a lot of these very similar to fungicides for powdery mildew or insecticides for mealybug. We need to have precise biological timing for that to work. And I don't think we have that because every nematode species has a different biological cycle in the system. And we tend to just lump them together. As I said, a lot of these post-plant nematicides are just, nematicide. It treats nematodes and you just put them on whenever, and it's not necessarily targeting a stage of nematode or the nematode species that you like. And we've done quite a bit of chemical testing on post-plant applied nematicides in my program and with Dr. Sasada down at USDA ARS. And typically what we find is it's just all over the board in terms of efficacy. And most fungicide or most nematicide labels have us put nematicides on in the middle of the summer or kind of in the late fall. And the challenge with that is if it's a product that targets eggs and it's applied in late fall, there's no eggs in the soil. If it's a product that targets J2s or the mobile stage and we put them on in the middle of summer, there's no J2s in the summer. There's mostly eggs in the summer and then there's J2s over winter. So it's really just hard to get the timing down for some of these post-plant nematicides. So maybe they would do better if their timing on the labels followed what the biological system is indicating they should. And that's just working on that over time. But I don't think long-term that's going to be our primary mode of nematode management, but it could help in situations where we just need to get a few extra years out of those vineyards. Rootstocks are a big one. We talked a lot about that. Many of you guys indicated that you do use rootstocks, and rootstocks are a good option for managing nematodes, but they're not, as we mentioned, 100% resistant. But I will say, in the context of Washington vineyard production systems, where we are dealing with own-rooted Vitis vinifera versus any other type of non-vinifera rootstock, any other type of non-vinifera rootstock for the most part does way better than own-rooted vinifera. And I can't overemphasize that enough, that we're going to show you some data here that says that some rootstocks are not necessarily totally resistant to nematodes, but they're still way better than own-rooted vinifera. And we see that with these numbers that are all over the screen here called a reproduction factor. And so a reproduction factor essentially measures that if you put a pest on a host, can that pest reproduce the next generation? So if that reproduction factor is 1, it means that is a susceptible host. The pest or pathogen is able to reproduce. If it's less than 1, it means it's a host that's not so good for the production system of that particular pathogen. If it's 0, it means that host is totally resistant. If it's more than 1, it means it's a super susceptible host and the pest does really, really well. So I'd like to point out those numbers. When we are dealing with own-rooted vinifera, Chardonnay, Riesling, Cab, Syrah, Merlot, these reproduction factors are anywhere from 9 to 45. So very, very good hosts. And so some might look at this and say, oh, well, if I have a nematode situation or problem in my vineyard and I'm growing Chardonnay, perhaps I should replant to Merlot because Merlot is more resistant. Well, yeah, but it's still a reproduction factor of 9. So still very, very high. And that's something to mentally process. When we translate that over and look at some own-rooted vines relative to existing rootstocks, we see very different numbers. So some rootstocks, are not so great. So 44, 53 here has a very high reproduction factor, but look at it relative to the own-rooted Chardonnay in this particular trial system. I do want to point that out. So you're going to see different numbers because every reproduction factor can change based on the timing and the level of inoculum. The reproduction factor itself, what you're interested is whether or not it's 1 or less. When it gets really high, it just means it's an overwhelmed system. So this just means it's growing like gangbusters. But look, 134 versus 0 or 2 versus 134. That's the level of difference we're thinking about or dealing with when we compare own-rooted Vitis vinifera to a lot of the commercially available rootstocks on the market. So it's a pretty big differences. The other thing, cover crops, we are not going to talk about that at all today. My program has a pretty big research footprint in looking at that right now, where we're looking at pre-plant fumigant replacement options for kind of reducing or suppressing nematode populations in soil, and post-plant suppressive options to kind of integrate undervine in a vineyard system. So there's a lot of really cool stuff out there. Again, we're doing a lot of work on that. A lot of other vineyard systems, especially California, New York, and Oregon, have worked quite a bit on cover crops. And I think this is a really exciting area to go into. They are not silver bullets. They won't completely kill nematodes out of your vineyard, but I think they're a really good complement to other potential nematode management approaches. So now we're down to the question, and we'll move pretty quick here. What have we been working on for the last decade? And it's to answer that question, is pre-plant fumigation actually worth it? So to fumigate or to not. And so we looked at two things. We looked at one, does fumigation reduce nematode numbers? Because that's typically how you evaluate fumigation. But more importantly, we looked at, does fumigating result long-term in the improved vigor or production or yield of a vineyard, right? Because something might reduce nematodes, but if you still have vigor, whatever's left still results in a vigor or production decline, and then it's not really doing what you intended, right? So nematode numbers are just a very raw way to look at if fumigation is killing nematodes, but we did monitor vigor and yield over time. And so I'm going to present two case studies, one on Red Mountain and one in the Horseheaven Hills. The reason why we're presenting two different ones is because the way the fumigant used and the way they were applied were very different. And I think that they have a similar story. So I think it's a nice thing to look at. So in this first case study, this is, again, a total vineyard replant scenario, but this is starting from a clean slate. So the vineyard was ripped out, and this particular plot was shank fumigated with Talone 2 at max rate of 35 gallons per acre. It was fumigated in April. The vines were planted in August, and we started sampling for nematodes in September, and we did so for a couple years afterwards. And what we found was pretty interesting and expected, because we started this trial after we had done our big trial, which I'll talk about next, and we saw similar results. So first year, so if you fumigate in the spring, plant in the fall, then 1 month later come back and sample, what we noticed is that in the fumigated plots there was barely any nematodes, and in the non-fumigated plots we found quite a bit of nematodes. It's not statistically different for those that kind of get into that statistical evaluation, simply because there was a lot of variability in our non-fumigated plots where some of them didn't have any nematodes either. And that is a hard part about doing field work with nematodes, is they tend to be very spatially dispersed around the vineyard. So that very first year, if that's the only time you ever looked, though, and you just got a report back in the mail of what nematodes you had, you probably would say fumigation worked because you couldn't find any fumigants. Okay, fair enough. I would potentially agree with you if I had gotten these numbers back and didn't have the ability to do the statistics or just had an average number. My conclusion would have been, yep, that first year my fumigation worked, moving on, time to start worrying about finding a buyer for that fruit. But when we came back 1 year later, what we found was the equivalent number of nematodes in the fumigated and non-fumigated plots. So by so essentially one full growing season, but 18 months after we had fumigated, there was no difference between whether we had fumigated or not fumigated that plot in terms of actual nematode production. And when we came back the following year, so 2 full growing seasons, or 2.5, if you count that first year as a partial growing season, but 30 months after treatment, same thing. At this point, soil sampling, you would have found no difference between fumigated and non-fumigated plots in terms of number of nematodes. So short term, did pre-plant fumigation reduce northern root knot nematode? Yes. Long term, it did not. This vineyard, we didn't track after 3 years, so we don't have the yield and vigor data, but that's the big conclusion there. We also had a small kind of area just outside of this vineyard where we did 2 different types of fumigation, where we did both Talone shanked and Vapam shanked. And we had the ability to kind of deep core to kind of figure out, where these nematodes might be. And the reason why that loss of efficacy, or what we're thinking is that loss of efficacy, is that the fumigation worked really good in the first foot of soil, but when we started to get down 2 to 3 feet, as you can kind of see over time, we see a lot more nematodes. Of course, you also see extreme variability. Again, nematodes are very, very hard to sample for. And you might see that Talone worked a little bit better than Vapam, but the big take-home message is that fumigation doesn't go where all the nematodes go, and that's probably why we see nematodes move back into the site after the year or 2 after fumigation. So our second case study is a very long-term trial up on the Horseheaven Hills. Most of you guys actually know it as our long-term rootstock trial, but it's this really big 10-acre design where we have a bunch of different rootstocks, and that's the fun part of that. But we also have a situation where we have sections of the vineyard that we fumigated, sections of the vineyard that we didn't fumigate, and sections of the vineyard where we didn't fumigate, and then we added additional nematodes because we wanted to see how long it takes for decline to start to show up and what kind of intensity of nematode feeding do we need. It's again, big, complex experimental design. You can read all about it because it was the 2022 best paper of the year through American Journal for Enology and Viticulture. So it's free to read. So you guys can look at that later. But again, this is a big trial up at Canoe Ridge on the Horse Heaven Hills. And so we ripped out or fumigated and treated and ripped out the vines in the fall of 2014 to spring of 2015, and then planted that vineyard in May of 2015 and have been following it ever since. So with this, we do a bunch of soil sampling in the spring and the fall, and we do a bunch of yield and pruning weights and all sorts of fun things. It's a pretty intense and very large trial. And this is what we see. So you're only looking at, I'm only going to show you data for the own rooted here, and then we'll talk about rootstocks. But I think what you're going to notice here is that it's a pretty complex story when you start thinking about fumigation more than just 2 to 3 years out, when you start thinking these 6, 7, 8 years out. So what you're seeing here on the far left are the nematode numbers in the plots before we fumigated. And so this is really nice because they're not statistically different. So it means that the nematodes were pretty equivalent in the plots that we planned to fumigate and then the plots that we didn't plan to fumigate. So that was nice. We fumigated in the fall. And then by the following fall, so 1 year after fumigation, if you look, yep, a lot fewer nematodes in that fumigated plot. So fumigation did what we thought it did. There's definitely more nematodes in the non-fumigated. Okay, these red bars here are the crazy nematodes, the plots that we added additional nematodes in, and as you'd expect, a lot more nematodes in those. So cool. It be that this plot 1 year after, science worked. It actually did what we thought it would do. And I mention that because not in field data, that doesn't always happen. So it did what we thought it would do. Excellent. 2 years now post-fumigation, what do we notice? Just like we saw on Red Mountain, there was no difference in the fumigated and non-fumigated plots. So from a practical sense, you as a farmer, again, fumigation is worn off. We have a lot of nematodes, again, building up in our non-fumigated and inoculated soils. And really what I want to point out, though, over the course of the rest of the study, what we start to see is if you look at the black lines, so these are the plots that are fumigated. And again, these are nematode numbers. You notice that they actually spike a little bit here about 4 years out, and then they start to come down again. In the non-fumigated inoculated, we get a huge spike, and then they crash, and we're starting to see them rise again. So we get these kind of boom and bust cycles. In the non-fumigated plots, so the plots that we did not chemically treat, and that we did not add extra nematodes, look at that boom and bust cycle. It is much more low key. So we kind of have this steady state of nematode population development happening in those plots where we're not getting these huge booms and busts. It's a pretty interesting thing to think about on how adding extra nematodes to a system or chemically treating the system might kind of throw the biological system off balance. But really, when we think about nematodes over time, while a soil sample is a snapshot, a perennial crop is not just experiencing nematodes in that one growing season, it's experiencing nematodes over many growing seasons, right? So it's what is that accumulative effect of constant exposure to nematodes? And we can calculate that using a process called nematode dosage. So it's like, what do nematodes, or what does the plant experience over time? And really what we see because we saw that kind of big boom in that in the nematode population in the fumigated plots, but several years later, by the time we're out in fall of 2022, so this past season, the accumulative effect on that plant, whether it was in a fumigated plot or a non-fumigated plot, is equivalent. So at this point, whether you spent all that time and effort fumigating early on versus not, the vine had experienced that same amount of nematode pressure over the long period of time. So that's kind of crazy, honestly, to think about all that time and effort. And now we're kind of in the peak of establishment, really in the production stage. And there's a fumigation at this point really doesn't have an effect in the sense that the plant is experiencing the same amount of nematode pressure. But when we look at our dagger nematode populations, that was a very different story. So in this situation, the non-fumigated plots have experienced constant kind of dagger buildup over time, where fumigated really didn't have a lot of, there was essentially no dagger nematodes those first few years, and it took a really long time for dagger to move back into the system. So in that situation, fumigation helped against dagger nematode, but here in Washington, again, we're not really interested in dagger nematodes. So I wouldn't choose fumigation as a means to control all nematodes in a vineyard system. You really should only think about it if you're worried about dagger nematode in your vineyard. But of course, nematode is one thing, nematode numbers are one thing. Are the plants actually showing any kind of stress or change in vigor? Did fumigation help us get us ahead in the system? And again, the answer, as you'd probably expect, is no. Whether or not, when we look at whether or not you fumigated or not, the plants are kind of developing at about the same rate in the own rooted. When we start to show data relative to rootstocks, you'll start to see a big difference there. But really over time, whether you fumigated or not, in terms of vine vigor, so in other words, pruning weights, we really don't see a big difference. Kind of early in vineyard establishments and the plots where we added a bunch of extra nematodes to, we saw the vines were pretty weak there. But right now, you would not have noticed whether or not that vineyard had been fumigated or not prior to planting. But we do see, again, a difference in rootstock. I just wanted to point that out here. So these are in the plots experiencing really high nematode pressure. This is from June 2021, so right during the heat dome. You see our own rooted vines look okay, but if you look over at our 10114 vines, we see a much better or more vigorous growth in those. And this is actually good vigor, not the bad vigor that we like to complain about from time to time. This is good vigor. We also don't see a big difference in yield, whether or not you fumigated or not. Again, so if you hadn't fumigated, it probably would have been just fine. But I will say tracking yield long-term in Washington for vineyard management is a bit difficult because of all the canopy manipulation we do. When we actually watched this particular plot is commercially managed for us, and we watched folks working in it doing shoot thinning. And what we noticed is they skipped all of our own rooted rows or the own rooted vines that were not doing well, and just didn't touch them, didn't do any shoot thinning, didn't do any canopy management. But when we got to our healthy rootstocks or the sections of the own rooted parts of the vineyard that were doing okay, they did much more aggressive shoot thinning and of course indirectly crop thinning because the clusters that came off those shoots. So again, in these larger commercial trials, it's often yield is not really a good number to track over time because that can be pretty heavily manipulated. But again, in this situation, in an own rooted vineyard at this stage, 8 years out, fumigation versus not fumigation, there's no noticeable difference in the vineyard. So the real question is can fumigation be effective long-term? And maybe it can with rootstocks. So if you think about an own rooted vine, within the first 6 months post-fumigation, yeah, it worked really well. But afterwards, the stress bucket of that own vine is totally at capacity because nematodes have built back up. But if you combined a rootstock with fumigation and a resistant rootstock where nematodes were developing more slowly, perhaps after 6 months, you still have more capacity in your stress bucket, if you will, for vine survival because nematodes are taking up a much smaller component of that. So that's something to think about, that if you're dealing with a really high nematode population in a replant situation, we now know that fumigation probably isn't your long-term solution, but it could be helpful if you couple that with a resistant rootstock, or just go to the resistant rootstock because that's probably doing most of the control for you. But just something to think about. And there are a lot of rootstock options that are going to be coming out, and I'm going to go over a couple of slides for you. We've already seen slides like this. This is that nematode dosage over time, and I wanted to show what that looks like. Not just a reproduction factor of a rootstock grown in a pot where nematodes are just feeding like crazy on the potted vine, what that looks like in the bigger system. So over 8 years in that vineyard, we did track how nematodes developed on own-rooted vines versus various rootstocks. And as you can see, even in a system where we have rootstocks that are allowing nematode feeding, they're still outperforming own-rooted vines. Really, the two species in this particular trial that have done really well, or the two varieties that have done really well, is 1103 Paulson and Tlecki 5C. So those have been really high-performing rootstocks for us. Harmony and 1114 have been moderately performing, but I will point out, even though these numbers are nematode numbers, if you looked at vigor, and if we kind of go back and compare some of those vigor charts with, which I didn't include here, but we've done elsewhere, Harmony might support more nematodes, but it has a really vigorous canopy. So you don't practically see the fact that it's hosting more nematodes. And that would only become then an issue in 30 years from now when you choose to replant, because it did allow some nematodes to develop on its root system. But really, I think what we're seeing is, while different rootstocks obviously behave differently against northern root knot nematode, they still way outperform own-rooted vines, not just in pot studies, but long-term. We see that again and again and again in our different research that Inga and I have conducted on different rootstocks. But that's part of the challenge, is most rootstock screens are not against northern root knot nematode, but against southern root knot nematode. And so you'll see an example here. So this is a situation of just kind of some cross comparison where rootstocks like St. George or 3309 by most practical standards are often listed as being very susceptible to root knot nematode, but that's because it's been tested against the southern root knot nematode. But when we test it against northern root knot nematode, yes, there's some development, but from a practical perspective, it's actually resistant to, or at least partially resistant to northern root knot nematode. And a lot of that, again, has to do with how aggressive these two nematode species are. So this is a good thing. So rootstocks that may not do so well in southern climates because they have southern root knot nematode might be okay to adopt in northern climates because our nematode species is less aggressive. And that's really where a lot of our future work is going on nematode evaluations. Is we're kind of starting to shift away from looking at some of these chemical approaches, again, looking at some of the cover crops, but also trying to do some additional rootstock screening for you guys to build up a better database on how rootstocks perform against the northern root knot nematode. Of course, ideally, we'd love to do that in the vineyard, so you knew long-term how that happens. But I don't think we have 15 years to test every single rootstock variety out there. So we do use those pot studies that I showed earlier where we calculate this reproduction factor. And again, it's not always super indicative of how that rootstock might perform long-term, but it's good enough, or at least it's a start, right, that we can work on. And so this is just a taste of that. Well, again, we always include an own-rooted control. Often we'll use a red and a white variety because we do know there's some differences, but we are evaluating rootstocks against various or different rootstocks against our northern root knot nematode. And most do pretty well. Again, 4453 tends to be one of our more susceptible control rootstocks that we also like to compare to. But for the most part, things do pretty well against our northern root knot nematode. So we're getting close to the end. And I actually hit my summary slide on time, so Melissa knows that that's rarely happens. So that's great. So our summary for this is pre-plant fumigation really doesn't provide lasting control of common plant parasitic nematodes when we're dealing with wine grapes as in a perennial, or one could argue in a perennial cropping system. Northern root knot nematode, though, the decline due to it is slow in Washington, and that's because it's that kind of single generation nematode species and it's not very aggressive. But that's a problem because it can sneak up on us. We don't really think about decline of, oh, it's been 10 years. How does this vineyard look? We think of what's happening right now. So we often forget that we need to think about nematode management in 10, 20, 30-year time spans, not months. A lot of the rootstocks that we use are not fully resistant to nematodes, but they're still better than own-rooted. And then, of course, when we start to think of long-term, overall, big picture, holistic management for northern root knot nematode, it's going to be a multi-pronged approach. I think in systems where there's really high nematode densities in the soil, you still may need to do fumigation to kind of just get you to at least give you a start to the season. But more importantly, the true long-term components are likely going to be a combination of rootstock choice plus post-plant cover crop type systems that you can tweak for your particular vineyard setting. I'm going to come back to this slide, but here's a bunch, if you'd like to read, here's a bunch of articles we've actually published in the last decade on our work here in Washington for nematode and rootstock evaluations. They are all published as open access, so we have prepaid so you can read them and not have to pay, and so you should be able to access those. And I will come back to this slide for those who like to use your smartphone to scan QR codes to access those. We have one more poll that Melissa's going to put up for us, and this is, what do you, when you do soil sample for nematodes, when do you typically do that? So we're going to have her launch that poll real quick. And again, this is question number 3. So just curious as of when you're soil sampling for nematodes in your vineyard. And we'll let Melissa make the call on when to close the poll for you. So when do you sample? Do you sample in the spring? Do you sample in the summer? Do you sample in the fall or winter? And note, my definitions of those seasons are different than the calendar definition of those seasons. So when are you sampling for nematodes? And so let's closing that. Oh, let's scroll down. We're sampling in the spring and the winter. Excellent. Those are really good options. And especially for those on root knot nematode, sampling in the winter is one of the best times to sample for root knot nematode, or October through that November to February period, provided your soils are not frozen, of course. So Melissa will close that poll. And then I think this next one, Melissa will correct me if I'm incorrect, but I think she at this time would like you to type, for those of you who have a WSDA or ODA pesticide applicator license and you would like to receive credit for attending today, she would like you to type your name, your license number and our secret code word that we talked about earlier in the session into the chat box. Melissa, you do have access to download the chat. Is that correct?
That's correct.
Perfect. So we'll have you guys do that in the chat box. And she would like you to do this now, because if you email her tomorrow, she may have already sent the stuff in. So do this now before we log off. You shouldn't, we have 5 more minutes. So again, your name, your license number, and the code word into the chat box. And then while we are taking questions, I'm going to open up the Q&A. I'm going to leave this QR code up for you guys, for folks who would like to scan that. And Melissa, I'm opening the Q&A and I'm going to answer some questions. I see stuff coming in. And
It's disabled. Why is it disabled?
are you going to, do you want me to put up your email address?